Okay, number 3, here we go. Okay, first thing to notice is they use the integral sign, but there are no numbers on that symbol. Therefore, we are not talking about an integral in this case. We are talking about only an antiderivative. So, now the symbols are extremely connected. That's why they use the same basic symbol. Because if there were numbers, our first step would be to find the antiderivative anyway. So this time we just don't have to do the subsequent step, which is to plug in the numbers. We just need to find the antiderivative. So here we go. First thing is you have to think of the rules and see if any rule will fit what we have in front of us. None of the rules are even close to matching because you only have 5 rules to use, and the rules are all really simple. They're things like the antiderivative of x to the n. Well, this is not the antiderivative of x to the n, so that rule doesn't fit. The expanded version of this rule is nearly a copy. It's the exact same thing, but instead of x, it's just ax plus b. So I don't memorize 10 rules. I memorize 5 rules and then just a simple pattern. So this is the basic rule. This is the expanded version of that basic rule. It's exactly the same thing except the x has been replaced with ax plus b, otherwise identical. So when you look at your reference sheet in blue, the left column is the basic rule. The right column is the expanded version. Questions? So I keep looking down the list. I'm like, okay, next rule. Next rule says, oh, I've got, let's see, e to the x. Well, this doesn't fit that rule either. The expanded version would be the exact same thing, except instead of x, I would have ax plus b. That also does not fit what I have here. So can't use that rule either. Questions? Please.
Are those rules on this sheet right here?
No, so you were gone last time, yeah?
Yeah.
So we got these last time. So you're good.
Yeah. I printed up.
Oh, you're good. So you got that one. Perfect. My bad. Other questions? Okay, when you hit a situation where the rules don't fit, we only have 2 options for our class. In other classes, you would learn more techniques, but for our class, just 2 techniques to worry about. The first technique is known as U substitution, so we're going to try that first. For U substitution to work, we have to be able to identify that we are trying to find the antiderivative of 2 functions that are being multiplied. Now, there are exceptions to that. The exception is sometimes one of the 2 functions can be a constant and it still works. But in most cases, we'll identify 2 multiplying functions. So I look at what I have and I say, okay, if I want this to look like 2 functions that are multiplying, I could think of it as being the antiderivative of x squared over 1 multiplied by 1 all over e to the x cubed. Now I have identified 2 functions that are multiplying. Another key thing is I'm going to teach you kind of a little process here, A, B, C, D, to H. As you get better at understanding U substitution, you'll notice I don't really follow the process anymore. The process is a place to get started. Okay? Once you can do it more easily, you don't really have to follow this exactly. So it's not like a set of rules, it's just guidelines. Pirates of the Caribbean. Okay? Questions? It's decent, that's light humor. Aggressive. Okay. So we have 2 functions that are multiplying. Now, the 2 functions that multiply typically, not always, but most of the time are going to fit one of these 5 patterns. So we'll go to MJ in the back. So MJ, the first of the 2 multiplying functions is this. Does that function fit any of these 5 patterns? Perfect, fits the first one. It is something to a number, 2 points for MJ. It is something to a number. The something in this case is an x. So that's a fit. Well, it says right here, we usually want to pick the u as the something. So we'll go to Sam. So Sam, MJ said this first of the 2 multiplying functions fits this pattern. We have something to a number. So what is the something in this case?
The x.
The x is the something. Well, that would mean that we would want to replace x with u. U substitution is the process of changing this from what you see into a brand new antiderivative where there are no x's, only u's. So we would want to say this. We want to say the u that we're going to pick is just the x. Well, it's never going to help to do this. It's never going to help to just say u is equal to x. You're not doing anything, you're just changing the letters. So that's not useful. So whenever you encounter that that's the substitution, that means that was the wrong pick. Like, we don't want to use that. Pause for questions. It's going to feel like really like random here for a minute until we kind of get the general idea that it will become more sequential. Right now I'm just kind of jumping around. Okay, cool. So now we look at the second of the 2 multiplying functions. We'll go to HT. So HT, this orange function, the second of the 2 multiplying functions, which of these forms? 1, 2, 3. It's not 4 or 5, of course. It's not sine or cosine. Which, does it fit any of those 3? 3. Definitely fits the third, 2 points. Here's the something. So, what's the something?
E to the x cubed.
So that means our choice would be u is equal to e to the x cubed. That's okay because that's not just substituting u for x, so that's a good thing. 2 points for Will. If this process feels very confusing, that's okay. It will feel confusing until we practice it a bit. It always does, so don't stress. Just try to make sense of what we're doing. We'll just do it again. So, okay, next step right here. So we have worked our way down the list. We found 2 functions that are multiplying. We found them both to be of the proper form. This item D is a reminder that these forms match the rules on the blue sheet. Almost. The blue sheet has a rule that says x to the n. It's not something to the n, but it is x to the n. Rule sheet has an e to the x formula, has a 1 over x formula, has a sine of x formula, has a cosine of x formula. So all of those forms do match the formulas, roughly. Cool. Next step. We've listed our choices for u. We have 2 of them. Here's one choice. Here's our other choice. For the reasons I explained, this is not a good choice. So we eliminate that choice. Questions? Oh, please.
Would you not say u equals x squared on that one?
For the second choice?
For the first choice.
Oh, the first choice. Gotcha. 2 points for a good
okay.
question.
Never mind.
Do you see why?
Yeah, well,
Yeah, the something is this part right here. So in this example, the something is just the x. Because it's something squared. No, that's a good comment. 2 points. Please, ask.
Could you have changed the fraction of 1 over e to the x cubed to just e to the negative x cubed and then done the e rule?
That's very good. In fact, we're going to have to go that direction in a moment. I just know it's perfect. I want to make sure you see why the way we're going is a dead end, so that you are prepared to make adjustments if you hit a similar dead end. That's where we'll go. So hold that for a minute, 2 points. Okay, the next thing right here says we are supposed to differentiate both choices for you. We do not need to worry about the first choice. I've already told you that's a waste of time. Don't worry about it. We need to look at the second choice. So we write down on our paper this. We take, let's clear this off a little bit. Move this out of the way. We write down this. So we have our equation, u is equal to e to the x cubed. We take d over dx. No, hold on a minute. Differentiate both sides of this side. Same thing on the other side. So now we're back to unit 2. That's what it meant right here when it said to differentiate both choices for you. Questions? So we'll go to Kennedy. So this side, Kennedy, we can't do anything here. No rule allows that to be written any differently. So we just write du over dx. We come over here though. We have a rule that will help us write that differently. How can that be written differently, Kennedy? Perfect. I'll give you 3 points for that one. Questions from anyone? It all ties together eventually, just does not tie together in the beginning. It just feels very random. If it feels random, that's normal. Okay, next thing says identify the correct u. Here's how we identify whether that's going to work or not. We have two multiplying functions. Kayla, shoot. Kaylee. Two E's on the other, not an A. Kaylee, our choice of u came from which of the two multiplying functions?
The bottom one, the one over x.
The second.
Yeah.
So our choice of u came from the second of the two multiplying functions. We take that u value, we differentiate that u value, we get this new thing here. If this process known as u substitution is going to work, this item here must be an exact copy of the other multiplying function, other than a multiplying constant. You can have a difference. You can have a different multiplying constant, but that black box has got to match this orange box if this process is going to work. If they don't match, the process won't work, and we have to find a different method. So I'm hoping that's pretty obvious that the orange box is not an exact copy of the black. Funny. 2 points. Okay. 2 for Kaylee and Tara. All right, questions? Okay, so we have to go a different route. The route we go is exactly what Aspen said. Can I clear the board and start fresh? Okay, so the route we're going to take is to say, oh, well, maybe we should have started with 2 different multiplying functions to begin with. Maybe it would have been better to say, what we really have is, we have the antiderivative of x squared multiplied by e raised to the negative 1 multiplied by x cubed.
So the
Yeah.
last entire problem that we did was just to show that that's a dead end.
It was, because the dead end is is, how do I say, it's not uncommon to hit a dead end and say, okay, I've got to back up and start over. So I felt like it was useful to at least demonstrate. Truth is truth, so facts. Okay, questions? Cool. So, Emmeline, first thing is to identify two functions that are being multiplied. So now, in our new attempt, what are the two functions that are being multiplied, Emmeline?
X squared and e raised to negative 1 x cubed.
2 points. So we have our two functions that are being multiplied. Oops, too far. We'll go to Blake. It says over here that both functions need to be of the proper form. So of what form is the blue multiplying function, Blake?
The first one.
It's the first one. It's something to a number. 2 points. So we'll go to Matthew on the front here. Matthew, maybe. So Matthew, if the blue function is of the form something to a number, what is the something I'm talking about?
X.
X. So one choice for you would be u is equal to x. Matthew, good choice or bad choice?
Bad choice.
Yeah, useless. That does not work. 2 points. Questions? Let's keep going. Let's go to Xander. So Xander, we go to the second multiplying function. What form is the second multiplying function?
The second one, e to something.
Yep, e to the something. So Xander, what is the something in that case?
Negative 1x.
Perfect. It's going to be a little bit light here because I should have used a different color. Let's change. So this orange function, the correct choice of u with regard to that function would be negative 1 x cubed. So far, so good. Keep going. Please.
So you only need one year for this one?
Just need one u. There are not always two choices. That's why it's a little hard to teach this, because it's not a recipe that always follows certain steps. It is a general idea that does follow this framework pretty nicely, but just have to be a little bit on guard for some flexibility. So I did find two choices. That's pretty common. Not always, but very common. I have eliminated one of the two. 2 points for Haley. I'm going to focus on the second. So we'll go to Delana. We're supposed to differentiate both choices. So what we want to do now is take this formula, apply the ddx operator to both sides. So the left side, can't really do anything. It's just du over dx. I can do something with the right side. How can I rewrite the right side, Dylan? Nicely done. 2 points. Questions? Let's go to Jake in the back. So now we need to see if we have identified the correct u. Right here. Have we identified the correct u? Well, what I said was, our choice of u, Jake, did it come from the blue or orange multiplying function?
Orange.
Came from the orange. Therefore, the derivative of our choice, this item here, must be an exact match for the other multiplying function here, other than they can have different multiplying coefficients, which they do. So this multiplying coefficient here is what, Jake? It's just 1. What's the multiplying coefficient here?
Negative 3.
Negative 3. Otherwise, they are a dead match. 2 points. This is really good news. I don't know how to draw, really happy. Okay. That looks creepy. I don't know what the sign is for really happy. Okay. Are we good? Cool. All right. what I want to do now is, now that we've kind of demonstrated how I'm thinking, I want to help you organize your work a little bit to make it so this process becomes easier. So we're going to start again, and I'm going to show you how I would organize the work. What I would have done, if I were doing this, a little bit of this foreknowledge, foresight. For example, I have done this enough, I could see exactly what Aspen saw, that I needed to go this way instead of the other way. Because I've done enough use substitution, I can do a few steps in my head. You'll get to the same point, everyone does. So what I would have done is this. I would have said I need to find that antiderivative. Okay, here's a strict rule. Look up. Okay, there are certain things that if you don't follow my process, it makes it so hard for me to help you. So I'm going to be very insistent that with use substitution, you need to have the same notation that I have, just so I can help you quickly. So it doesn't take me a minute to go, what the heck are you doing? And then I finally find it, like, okay, your thinking's fine, but your writing is just so different than mine, I can't follow. So you're going to solve this problem in 2 columns. So you're going to use the whole page. Okay? But you're going to do part of your work here, part of your work here. So we're going to do the main problem straight down like we always do. We're going to mess around with our choice of U over on the right. So here we go. What I would have done is I would have simply looked at the problem and said, I want to rewrite what I have to begin with. So I would write equal, and I would have written x squared multiplied by e raised to the negative 1 times x cubed dx. That would have allowed me, with a little bit of foresight, to say, hey, I can tell that the only possible choice for u here is negative 1 multiplied by x cubed. The other choice isn't going to work. There's no reason for me to write it down. I would do the next step in my head. Let's go to Matthew Harmson. Matthew, what is the derivative of that? Negative 3x squared. I would mentally come over here and say, that derivative is supposed to look just like that, other than a multiplying constant, which it does. So I know I'm on the right path. 2 for Matthew. So I do the derivative, du over dx. You can shortcut it. You don't have to write out d of dx of that thing. You can just write negative 3x squared. Questions? Okay, the name of this technique is called U substitution. We are literally going to change out every single item on the left that involves something with x. So this, and this, all of those are going to be changed into something involving u. And we have to make legal substitutions. So we already have one legal substitution that we can make. It's right here. Because it says, anywhere we see negative 1 x cubed, we can write u instead. So let's do that. So come back over to this side, write another equal sign. Notice, we're going straight down the page here. So straight down the page. So we go, this becomes, let's see, we have x squared. Oh, another trick. It does help to change the order. We're going to change this. We're going to replace this with u. So let's write this first because the order of the factors doesn't matter. So this becomes e to the u multiplied by x squared dx. We have made one replacement. Questions? The y will appear in a moment.
Okay.
2 more for asking.
Okay.
Anybody else? Awesome. Okay, I said that we need to take everything that involves x and replace every item that involves x with something involving u. We've done part of that right there. So we've got to work on this now. So it's all about the equal sign. I want to pay points to the whole room. It's all about the equal sign. Raise your hand if you can see how to rearrange this to create this. You can do it. It's algebra. Hands up. Remember, this means du divided by dx. They're separate. They're just dividing. So how can I use algebra to change this equation into a brand new equation to create that? There we go. Getting a few more. Let's go with Ellie. Perfect. So I multiply both sides by dx. That gives me du is the same thing as negative 3x squared multiplied by dx. 3 points for Ellie. Let's go to Ella. Say again. 2 points. I can't actually do that because it's not d separate from u, it's du as its own single item, so I can't do that. Another reason I don't want to is I really want to get dx. Like I want to find x squared times dx. Keep going, Ella. There we go. Negative 3. Dividing by negative 3, no different than multiplying by negative 1/3. I prefer to multiply. And I'm done. 3 points for Ella. I have successfully found the other item that needs substituting. Right there. So I do that step. Equal again. Antiderivative, e to the u, multiplied by, don't forget the parenthesis, negative 1/3 du. We have successfully transformed an antiderivative where everything involved x to an antiderivative where everything involves u. Questions? Please.
It's just all seems very confusing.
Say again.
It's just all seems very, very confusing.
If it feels confusing, the best I can tell you is it always does the first time it is discussed. We just have to be patient and work out it. 2 points for very valid observation. I like to, I can't remember which student did it, they didn't leave me a sign. They made an interesting little joke about this. They said, oh, this is like dating. What you want to do is, at some point when you're dating, you'll decide that, yeah, it's time to move on. I've spent enough time with this fellow. I don't really want to spend time with him anymore. And so you want to leave your, this is a really dumb joke, you want to leave your ex behind. And take some time for yourself. Make it all about you. I told you it was a bad joke. Okay. I didn't get any laughs. Like I feel like, bad joke.
That's good.
It's good. It's,
Yeah. So true.
there's some truth to that, right?
Yeah.
Yeah, you focus too long on your ex. Like, stop thinking about that. Spend some time for yourself. Just make it about you. So. Well, there's that. The joke was bad. Okay. Okay. All right. Next step. So first question, Kaylee. Like Blake said, okay, when I saw this at your age, I was like, what just happened? Like it felt really weird. Oh, time out. Yes. Yes.
Yes.
Yes.
2 tickets in one day. There you saw it perfectly. That's the whole idea. Here's what she just saw. I'm right here. I've got this new antiderivative, which seems a lot simpler than the antiderivative I started with, because this is a multiplying constant. Therefore, that can be pulled out of the antiderivative sign. And now I look at my blue sheet, and hey, other than u instead of x, I have a rule. It's a perfect match. So, Peyton, according to the blue rule that looks just like this, what is, the blue rule says this can be written, not that part, sorry. The blue rule says this can be written differently. What does the rule sheet says I can write that as? Yeah, and they're just using x, we'll just use u. So this is negative 1/3 multiplied by e to the u plus a constant. 2 points for Peyton. Questions?
And for like multiple choice, you just put back in the x.
Nice. Up here it tells us u and negative 1x cubed are the same thing. So we make another substitution, 2 for Aspen. Last thing they did is they wrote that a little differently. They said, oh, okay, so this is negative 1/3 multiplied by 1 over e raised to the x cubed. And we have found our answer. That's the antiderivative. Put on my chair there. Anybody else? Seems like cheating, is what you're saying. Yeah, agreed. I am a huge proponent. Let's make sense of the math. This one has, for years, it's a little hard. It's tricky. Okay. Last thing we want to do, just to make sure this, it'll help your brain feel better about it. Maybe. So right here, let's see who's going to get to help me. Right here, we have our antiderivative. Let's go to Gabe. If I take the derivative of this blue formula, Gabe, do we know what we would expect, or do we have no idea what we should expect? Nice. Not this per se, because that's got the antiderivative symbol, but this part here for sure. If I take the derivative of this blue item here, I take the derivative of that blue, I must get the yellow. 2 points for Gabe, so let's try it. So, I want d over dx of negative 1/3 e raised to negative 1 x cubed plus a constant. If I take that derivative, I'm supposed to end up with this item up here in yellow, right there. Questions? Let's go to Lucas. So Lucas, talk me through what I write on the next line here. So I'll help you. So the negative 1/3 is a multiplying constant. We just write it down. Now we have the derivative of e to the something. What's the derivative, Lucas, of e to the something?
It would be e negative 1x to the 3rd.
Perfect. Pause for a minute. So it's e to the something. Keep going. I knew you knew it, so keep going.
And then negative 3x squared.
Nicely done. Derivative of the something would be negative 3x squared plus the derivative of the c, Lucas, would be 0. 3 points for that one. Questions? Cool. So Jackson, when we look at this, are we looking at factors or terms?
Factors.
Good. So we can combine any we choose. which are the two most logical factors to combine first?
I'm not sure.
So what are the factors?
Negative 1 squared, e1, and then negative 3x squared.
I would have said -3
Okay.
and then x squared. You're doing fine. So can you see two of those factors that really do combine quite conveniently?
Negative 3 and negative 1/3.
Good, they combine to make
1.
+1. 3 points for Jackson. So now all we have is e to the -1x cubed multiplied by x squared. Hey, there we go. Just what we wanted. Black magic. Cool. It's not magic at all. It's just using the equal sign. That's it. It's just taking advantage of equal. That's all they did. Like you just follow the equal sign, it always works out. Questions? Solid. Let's do another one. Cool. So let's stop that video.